Imagine you're standing in the middle of the Inca Empire. The walls around you aren't painted yellow, they're covered in sheets of solid gold. To the Inca, this wasn't money, it was the sweat of the sun itself. Half a world away, the ancient Egyptians believed gold was the literal flesh of the gods. The Greeks imagined kings cursed by it. Across civilizations that never met each other, humanity kept reaching the exact same conclusion. Gold couldn't possibly come from Earth. And here's the strange part, they were almost right. Because the gold in your wedding ring, the gold inside your phone, even the tiny flakes locked inside Earth's crust were all created long before our planet even existed. Long before the sun. Long before anything you would recognize as home. This is the real story of where gold actually comes from. Let's start with a star. A star spends its entire life fighting itself. Gravity pulls everything inward while nuclear fusion pushes outward. As long as those forces stay balanced, the star survives. Inside its core, hydrogen becomes helium. Helium becomes carbon. Carbon becomes oxygen. With enough time, larger and larger elements are built like cosmic Lego bricks. But eventually, every star hits a wall. Iron. Iron is different. Every fusion reaction before iron releases energy. Iron does the opposite. The moment a star's core fills with iron, the engine keeping it alive shuts down. Gravity wins. The star collapses. For ordinary stars, that's the end. And here's what most people don't realize. Gold is nowhere near iron. Gold is element 79. A normal star like our sun will never produce a single atom of it. Not one. Because making gold requires something far more violent than an ordinary star can ever become. It requires one of the most extreme events in the universe, a neutron-star collision. Imagine squeezing the mass of our entire sun into a sphere roughly the size of a city. That's a neutron star. A single teaspoon of its material would weigh billions of tons. Now, imagine two of those monsters orbiting each other faster and faster until they finally collide at nearly 1/3 the speed of light. For a fraction of a second, temperatures reach billions of degrees. Matter is crushed beyond imagination. Atomic nuclei are bombarded with an impossible number of neutrons before they can even react. This is called rapid neutron capture, the R process. And it's here that gold is born. Not mined, not forged, created. For billions of years, astronomers suspected this was how heavy elements formed. Then, in 2017, humanity finally watched it happen. Two neutron stars collided 130 million light years away. First came gravitational waves, then gamma rays. Hours later, telescopes captured an explosion unlike anything ever observed before. A kilonova. As the brilliant blue glow slowly turned deep red, scientists realized they were witnessing radioactive heavy elements being created in real time, including gold. One single collision likely produced several Earth masses of it. Think about that. Every gold ring ever made, every coin, every treasure chest, every Olympic medal. All of it would barely register compared to what one neutron star merger creates in seconds. But that raises another question. If gold formed in deep space, how did it end up beneath our feet? The answer is stranger than you might expect. Around 4.6 billion years ago, our solar system began forming from a giant cloud of gas and dust already contaminated with heavy elements from ancient stellar explosions. Gold was already floating through space before the sun even ignited. As Earth formed, nearly all of that gold should have disappeared forever. Gold loves iron. Geologists call it siderophile, meaning iron-loving. When our young planet was still molten, liquid gold followed liquid iron straight toward Earth's center. More than 99% of Earth's original gold sank into the core. It's still there today, enough to coat every continent in a layer of gold almost half a meter thick. The problem? It's nearly 3,000 kilometers below your feet. Completely unreachable, so why can we mine gold at all? Because Earth got lucky. After the core had already formed, our planet was bombarded by countless asteroids. These space rocks carried fresh supplies of gold that never had the chance to sink into the core. They stayed trapped inside the crust. Every gold mine on Earth exists because of this second delivery. In other words, almost every piece of gold humans have ever touched literally fell from the sky. And sometimes space gave us another helping hand. South Africa's Witwatersrand Basin has produced around 40% of all the gold ever mined. That treasure almost disappeared forever. Ancient rivers concentrated the gold, but erosion should have washed it away long before humans evolved. Then another asteroid struck. The enormous impact tilted the gold-bearing rocks and preserved them beneath the surface for billions of years. Without one asteroid delivering gold and another preserving it, human history might have looked completely different. There's one final mystery. Why is gold yellow? Most metals are silver. Gold isn't. The answer isn't chemistry, it's relativity. Gold's inner electrons move at nearly half the speed of light. At those speeds, Einstein's equations begin changing how the electrons behave. Instead of reflecting every color equally, gold absorbs blue light and reflects yellow. Without relativity, gold wouldn't look golden at all. It would look silver. Think about how incredible that is. Ancient civilizations believed gold was divine because of its color. Modern physics discovered that its color exists because the universe itself follows Einstein's rules. So where did gold actually come from? Every piece you will ever hold is older than the Earth itself.